One of the first things we have to learn in this course is to distinguish between vectors and scalars. Physics uses a lot of vectors, but in earlier science courses you have seen distance-time graphs, which is a scalar phenomenon with distance time. For example, a car begins a trip by traveling 10 kilometers in 10 minutes and stops for 5 minutes, then travels 5 more kilometers in 7 minutes, can be shown like a graph at the bottom of the screen. At the beginning we start with a zero time, and we're measuring from where we start, so the distance is also 0. And then over the first 10 minutes, the car goes a distance of 10 kilometers, so we have a constant speed during this time. Here, the car stops, so the slope is 0, not moving, for 5 minutes. And then the car continues on for an additional 7 minutes to go 5 more kilometers, up to a total of 15 from where the person started at. This is a distance time graph. Now, a few more distance time graphs. Some simple ones here. We can use a line to represent someone walking. We'd probably have a fairly shallow slope because you don't tend to walk very fast. Okay. And if a person was running, we might give them a steeper slope, because if they're running, they're covering more distance in the same amount of time period compared to a walking graph. If they're running faster still, we would increase the slope even further. So you can certainly tell now, what does a steeper slope mean? The higher the slope, the higher the gradient, if you prefer that word, the faster the person is moving. These are still distance time graphs. In class, we'll make a guess as to what a graph might look like if we have a situation like this, where a person walks forward, stops, then walks backward. So I'll let you ponder that for now, and we'll see what's under here in class. Okay. Typically, classes make two main guesses that split the class, and we'll see that there are some problems with the way we think about these situations that can't be completely covered by a scalar like distance, and we move instead on to displacement. In general, scalars are quantities that have magnitude, but no direction. For example, things like energy, time, and distance. Vectors are quantities that have both magnitude and direction. Okay, things like displacement, acceleration, velocity. There are some examples given on the Prezi after this. A vector is drawn as an arrow on a graph. The arrowhead points in the direction of the vector. On a scaled graph, the length of the arrow is proportional to the magnitude of the vector. That's quite important on a scaled graph, and even in sketches you'll be expected to roughly have your vectors drawn proportional to each other. So a vector that's supposed to be twice the magnitude of another should be twice the length of another, and so on.